So hi friends, now today we are going to discussing about voltage current relation for passive bilateral elements for different input signals. Okay, means simply already we know that there are different types of passive elements is there. So that is like either resistor or inductor or capacitor. Okay, so that is like resistor. That is like resistor, and also so second one is the inductor, and third one is the capacitor. Okay, already know that I think. Okay, so there are different types of elements is there. So according to the all those elements we have to represent it into the voltage and current and power equations. Okay, so means whenever the input supply will be given to the both all those passive network elements, so then we can get to the sum of the different types of voltage also occurring, and also currents also we are getting according to the both multiplication of voltage and current. Finally we can get into the power also here. Okay, here bilateral elements means, so that is like a passive network elements. Okay, here whenever the input supply will be given to the all those we are getting. So now we have to see here. Okay, so if we want to go for the resistance according to Ohm's law, so how can we represent it? V is equal to IR. Okay, V is equal to IR. Okay, and also so from this we have to representing R is equal to V by A. R is equal to V by A. Why? Because here only needing voltage, so that's why we have to representing like this. V is equal to IR. Okay, and also if you want to go for like a current equation for the resistance, I is equal to V by R. I is equal to V by R. And also if you want to go for like a power equation, P is equal to, here we are to representing I square R. Why? Because here resistance is there. Here total power based on the voltage and current. Okay, so that's why we have to representing P is equal to I square R. So that is like a some ohmic losses. This is also called as like a ohmic losses. Okay, that is called as I square R. Okay, and also if we want to go for inductor, so what is the voltage equation? What is the voltage expression we are getting from the inductor? So simply we can get into the V is equal to L into di by dt. Okay, here di means change in current, dt means change in time. Okay, so that is given as V is equal to L into di by dt for the voltage equation of inductor. And also if we want to go for the current expression, okay, simply we have to represent it I is equal to, so I is equal to 1 by 2 into integral V dt plus I naught, plus I naught. Okay, here I naught is the initial current in the inductor. Okay, so when we are supply will be given to the inductor, so then only at initial condition what is the current will be producing, that current can be we have to represent it like a I naught. Okay, so that is given as 1 by 2 into integral V dt plus I naught. This is the current equation for the inductor. Okay, if you want to go for the power equation, P is equal to, okay, P is equal to L into di by dt. P is equal to L into di by dt. This is the total power equation. And also if you want to go for the capacitor, for the voltage expression for the capacitor, which is given as V is equal to 1 by C into integral I dt. Integral I dt plus V naught. Okay, please remember that, very important. Why? Because these are the both I naught and V naught is the initial voltages, initial current and initial voltages. So please remember that where V naught is the initial voltage across the capacitor. Okay, and also if you want to go for the current expression for the capacitor, here I is equal to C into dV by dt. I is equal to C into dV by dt, change in voltage with respect to time. So this is the current expression for the capacitor. Okay, and also if we want to go for the finally power equation for the capacitor, here so total power which will be given as P is equal to CV into dV by dt. dV by dt. Okay, so this is the final total power equation for the capacitor. So which can be we have to represent it between the current and voltage. Okay, so all those which is very important while doing the problems on both inductive elements as well as capacitive element networks as well as resistance element networks. Okay, so all those voltage and current expressions, which is very important. So I think you are understood what I am saying. Okay, so thank you one and all. Thank you.